Okay, I haven't balanced audio levels or anything yet here because we have the Artemis II Rollout and Mission Overview Conference happening right now.
This is space. I'm in
Hokey,
space.
this is space. We're going to space. Going moon. 10 subs. Thank you. All right, what's going on, everybody? Okay, so here. I'm just gonna pick up the press conference coverage from here. Let's roll. Hokey, thank you so much, man. Love you. All right, let's roll.
I'm Rachel Kraft from NASA's Office of Communications, and welcome to our briefing today to preview Rollout and the Artemis II mission.
Underboosted.
We're joined today by several NASA managers here to share more about how those preparations are going for the mission, and they are John Honeycutt, Chair of the Artemis II Mission Management Team, Charlie Blackwell Thompson, Artemis Launch Director, Jeff Radigan, Lead Flight Director
Jeff's
for Artemis
cool.
II,
That guy's awesome.
Lily Villarreal, Landing and Recovery Director for the mission,
All right, let's roll.
and Jacob Bleacher, Chief Exploration Scientist for NASA's Exploration Systems Development Mission Directorate. We'll have some opening remarks from each of our participants, and then we'll get into some questions and answers. And we'll take those questions from those here in the room and those joining us by phone. And with that, we'll start with you, John.
Okay, thank you, Rachel. Hey, happy to be here today. You know, these are the kind of days that we live for, and when you do the kind of work that we do, the rocket and the spacecraft, Orion. Integrity, getting ready to go to the pad and rolling to the pad. This group of folks to my left, as well as many others across the agency, are here. We're here representing a lot of folks that have done a lot of work to get us to where we are today. I'll just say it really doesn't get much better than this, and we're making history.
Yeah, baby.
I was around for Artemis I, and this one, I think for us, and I know probably for you too, this one feels a lot different. Putting crew on the rocket and taking the crew around the moon. This is going to be our first step toward a sustained lunar presence on the moon. So it was 10 days, 4 astronauts going further from Earth than any other humans ever traveled. We'll be validating Orion spacecraft's life support, navigation, crew systems in the really harsh environments of deep space, and that's going to pave the way for future landings. Talk a little bit about the mission management team. That's a group of 15 core members from across the enterprise that are responsible for the overall risk management associated with the mission. Myself, as well as the members of the mission management team, have taken part in every one of the mission reviews and all the risk assessments that we've done to date so far. Right now, the mission manager, who is different from me, he's running the show relative to the overall Moon to Mars mission management for Artemis II, and he's the deputy for me as the mission management chair. And then when we get to the L-2 day mark, all of his responsibility relative to managing the mission will get turned over to me and the mission management team. Once we're flying, the MMT is going to be providing strategic direction for the operation teams, whether it be Charlie and her team leading up to launch, or Jeff and his team for the in-space operations. Shortly after we launch and get into proximity operations demonstration on launch day, we'll begin to meet daily at JSC throughout the mission. Now, as chair of the MMT, I got one job, and it's a safe return of Reed and Victor and Christina and Jeremy. I consider that a duty, and a trust. And it's one I intend to see through. Alongside the MMT
Attaboy,
Deputy Chair, who I mentioned earlier, and the entire MMT. So to that end, I will tell you, we're going to fly when we're ready. From launch through the mission days to follow, the crew safety is going to be our number one priority. Thank you. Rachel.
Charlie.
Hi, well, good morning, everybody. I'm Charlie Blackwell Thompson. I'm the Artemis Launch Director. It is wonderful to be in this room because when I'm here with all of you, it means that there's a milestone upon us, and we are approaching a big one for us as it relates to Artemis II tomorrow. You can see from the picture that was put up earlier, and I think we have another graphic, all of the platforms in the vehicle assembly building are retracted. We are on track for our rollout tomorrow morning. First motion is planned for 7 a.m., and many of our teams will be coming back in on third shift to make those final preparations and get ready to roll, like I said, at first motion. 7 a.m. Takes us a little while to get out of the building, but about an hour after we get that first motion, you'll begin to see this beautiful vehicle cross over the threshold of the VAB and come outside for the world to have a look. We'll retract the crew access arm. That'll take a little bit of time, about 45 minutes or so, and then we'll pick up and we'll head out on our 4-mile journey to Launch Complex 39B. We'll be at a cruising speed of just under 1 mile per hour. It'll be a little slower around the turns and up the hill.
That's pretty fast
that journey
for the
will
CT,
take us
dude,
about 8 to 10 hours to get there.
With 16 million pounds of rocket
Once we get
on
out to the pad, we'll begin and get hard down. We'll begin our connects to the facility. Connecting our commodities, getting through our validations, getting connected back up to the firing room. We'll get prepared to power up the elements. We have some crew access arm swings that are going to happen out at the pad. When we first get out there, we've got emergency egress system to configure. We'll get ready for our pad testing, which is called pad PSET. It's a lot of our RF checkouts that we do. And we'll do our booster servicing, and we will get ready for wet dress. We do have a walk down with the crew called CDDT Part 2. It's a walk down of the emergency egress system once it's configured. We'll take care of that somewhere in and around our preps for wet dress is the plan right now based on the crew schedule. And wet dress, we'll fully tank that vehicle. We'll go through all of our tanking ops. Will go through our day of launch configuration, and provided everything's nominal, the launch director, myself, I'll make the decision to send the closeout crew out to the pad, and we will do the final closeouts for launch. We'll go through our terminal count, and we have a planned cutoff at T-minus 29 seconds. We'll take some time after wet dress. We'll review the data, and then we'll set up for our launch attempt. Launch day will be pretty similar to wet dress. There'll be 2 big differences. One is that we're going to send the crew to the pad, and the other one is we're not going to stop at 29 seconds for a planned stop. So that's a little bit about our road to wet dress, what's entailed in wet dress. Again, launch will come along after that. We talked about, I think at our prior briefing, a little bit about our countdown, leveraged off the Artemis I countdown. I do have a couple of changes in our holds in the countdown. We have 3 planned for Artemis II. Just like we do on launch day, right? Part of launch, we'll get into our terminal count. We'll count down. As I said, don't plan to stop at 29 seconds. Plan to go all the way to T0. We'll get down to core stage engine start inside of 6 seconds, six-ish seconds, booster ignition and liftoff. And at that point in time, I'll hand off to the Ascent Flight Director, just like I'm going to do today when I hand off to my colleague here as part of the briefing, Mr. Jeff Radigan.
Thanks, Charlie. It's a great day to be here talking to you all. Over mission control, of course, we're doing our final simulations, getting ready.
Not to talk over Jeff real quick, but this guy is cool. He's a flight direct. Jeff is cool. Listen to this dude.
You can see in the video here that, as Charlie mentioned, we get liftoff, and then the core stage and boosters are going to take us to orbit. And it's going to be a monumental day. We're really looking forward to it.
What's that about?
Let's see. So I will talk through a little bit of just an overview of the mission. Of course, we'll get the boosters jettisoning there a couple minutes into launch, and then the core stage will boost the upper stage, ICPS, and the Orion spacecraft into orbit. At that point, we'll actually separate from the core stage and then go ahead and deploy the Orion solar arrays, setting ourselves up into a low Earth orbit to start. We'll spend a couple hours in low Earth orbit. And then the upper stage will do the apogee rays burn that will take us into a high Earth orbit, where we'll spend about 24 hours checking out the Orion systems, life support systems, crew systems, ensuring everything's ready. Along the way, we're going to do a ProxOps demo. And see, once this video completes, we'll cue the ProxOps demo video. And the crew's going to get a chance to fly the Orion spacecraft for the first time around the upper stage, and that's going to be great for us. I mentioned the crew readiness. They're undergone all of their training, and I Reed, Victor, Jeremy, and Christina. They're all ready to get on the rocket and get on with the mission. It's one of the interesting things. I don't think they can get enough training. You always want more, to the point where we're actually installing, I think, their cockpit in quarantine, so they'll be able to do some last-minute training. But from my perspective, they're ready to go. Here you can see a video of the ProxOps demo of what we're going to do. We're actually going to separate. We're going to turn Orion around, and then the crew's going to pilot the spacecraft around the upper stage, the ICPS. This is what is going to give us data to ensure that we can dock on future flights. We're all looking forward to being able to dock with a Starship in the future, or a Blue lander. And on Artemis II, we're going to ensure that all of our models, all of our systems work successfully to be able to do those future dockings as we're in that high Earth orbit and doing a checkout. Let's see, after we get into that high Earth orbit and we do the checkout, of course, we'll consult with Mr. Honeycutt and the mission management team, make sure all systems are go for the translunar injection burn, and we'll take the crew to the moon. So let's see if we can cue the next video, please. It takes 3 days to get to the moon, and the crew along the way is going to be doing some additional, more detailed checkouts of the spacecraft. We'll ensure that we've got a good, healthy spacecraft before we leave Earth. But then, of course, this is a test flight. We want to put Orion through its paces. And then as we fly by the far side of the moon here, the crew is going to spend a day in lunar observation. So they're going to basically spend the day giving their observations on the far side of the moon, which hasn't been seen, parts of it hasn't been seen by human eyes before. So that'll be a great opportunity. And of course, they're going to take a fair amount of video and just have those observations. I will caution you that they're a long way from Earth, and signals are a little weak at that point. So we will get some video down, but the real high definition video will be post-flight when they come back. Finally, they're going to head on back home here and get ready for entry. It's a long mission. 3 days there, a day around the moon, and 3 days back. All of that to say that we have to set them up for entry successfully, right? Our one job, as Mr. Honeycutt said, is to bring the crew home safely. We need to hit the right entry interface corridor and bring them home. And once we do that, then the Orion will split into two. We'll have the CMA and the service module come off the crew module, which will then come through re-entry. And we've got a whole series of parachutes that slow down. We're going much faster coming from the moon than we are in low Earth orbit, and so we need to slow down a little bit more, and it takes more parachutes to do that. And so here we've got a video of what the re-entry sequence looks like. Of course, the crew's protected by the heat shield, and we'll go through a blackout period where we can't talk to them, and then come out the other side underneath the parachutes. Let's see. I do want to mention this is a test flight, and there's things that are going to be unexpected. I think we've prepared for those as much as we can, and we're very much looking forward to flying this mission successfully with the crew and learning what we need to on Artemis II moving forward, and paving the road for future Artemis missions. let's see. Next, I'll hand it over. Once the video here completes and when the crew gets down safely, of course, we hand things over to Lily and her recovery team to go pick them up.
Thank you, Jeff. If you can't tell, I'm just a little tiny bit nervous. So I want to really talk to you about recovery, and I represent such a wonderful team. So
did you guys see how the plume was changing? That's the Artemis 1 re-entry. You see how the plume was changing shape? That's the RCS on the capsule, firing and rolling the capsule to steer the thing down to a precise landing. The RCS has interaction with the shock, with the shock coming off of the heat shield. That's why the plume changes shape during landing, or during re-entry.
Coast of San Diego. The recovery ship will approach the landing zone, and a team of Navy divers
that was Artemis 1
in small boats will deploy from the ship into the open water. Prior to splashdown, a team from Johnson Space Center will map where the elements are jettisoned from Orion, such as the forward bay cover, the drogue parachutes, and the mortars. And this is to make sure that our boats and helicopters supporting recovery stay clear of all this debris. The divers will be the first to approach Orion, and they will conduct assessments of the air and water surrounding the capsule to make sure that it's safe to approach and help the crew exit Orion. After ensuring the area is safe, they'll open the Orion hatch and help the astronauts from their seats to a large inflatable raft called the front porch. Once all the four astronauts are on the front porch, we will tow the capsule away from the front porch, and the team will pick up from the Navy helicopters, which are deployed from the recovery vessel. 2 helicopters are going to rotate, picking up all the 4 crew members before they return to the recovery ship within a few minutes of each other. Once the crew has exited the helicopters, they're going to proceed straight to the ship's medical bay to undergo routine post-medical checkups. We expect to recover the crew and deliver them to the med bay within 2 hours of splashdown. With the crew safely out of the capsule and in tandem, we're going to be recovering the capsule. Teams are going to work on towing the Orion into the well deck of the ship, pretty much similar to how we did that during Artemis 1. The Navy divers will ensure that a system of lines are connected to the capsule to ensure that we can help tow the Orion vehicle onto the ship. When Orion is close to the ship, an additional line is going to be attached to a pneumatic winch that's inside the ship, and that's how we're going to pull the vehicle into the capsule. Once Orion is safely inside the ship, we will start making our return back to Naval Base San Diego. Depending on our distance or when we land, the Artemis II crew will either fly off the ship back to shore, or they will ride with the recovery vessel back to San Diego. Once we arrive back to shore, the astronauts are going to depart to go to Houston, while the NASA recovery team will complete some post-splashdown processing activities of Orion before we transport it back to Kennedy Space Center. Some of those tasks that we're going to do is perform all the initial assessment of the capsule. We'll remove some science payloads that need to be expedited, returned back to their original NASA center, and then we'll be ready to transport it back. I do want to take a moment to say that we want to thank our partners from the U.S. military who are supporting our Artemis recovery operations. Without them, we really could not have done that, and they have been there with us since the early days of human spaceflight. Our joint NASA, Navy, and Air Force team, we've been training for several years together to ensure we have a seamless recovery of Orion and the Artemis II crew. We had a very successful recovery of the Orion spacecraft during Artemis 1, and we feel confident that through our testing and training, along with the Navy and the other collaborations that support us, we will make Artemis 2 just as successful. Thank you.
Awesome. Thanks, and thanks, Lily. And I just wanted to say, being nervous is just one form of extreme excitement, and I hope that you can all tell how excited we are right now. I did want to start by saying what a privilege it is to be here, and an honor it is to be a part of the Artemis II team. I want to echo some of John's words earlier. That's not just our colleagues here at this table, but the thousands of people who have worked on Artemis II over the years, including you all. Thank you for being here to help us relay this information and tell this story. I have a song that I like to play often as I approach the VAB, Vehicle Assembly Building, for big events. It's the kind of song that makes the hair stand up on the back of your neck or on your arms. I'll confess I played that song this morning.
What song?
Because this is a very historic moment, an exciting moment. We're rolling out the integrated SLS in Orion for a flight that will carry 4 of our friends, our NASA family members, around the moon and bring them safely back to Earth. Artemis II is a test flight. It truly is exploration. There will be a number of firsts that we'll be proving out on this flight. And I like to say that during exploration, science is our toolbox for survival. With that in mind, I'm excited to present to you our Artemis II Integrated Research Campaign, which involves activities across biology, human research, space weather research, and also some planetary geology. Our integrated campaign is designed to help unlock more time for science on future missions by minimizing crew time spent on other activities and increasing crew and support team efficiency on the science tasks themselves, all while learning how to best thrive in the deep space environment. During this flight, we will learn how the spacecraft behaves. Through our research campaign, we will also learn how we, human beings, behave in that same environment. The combination of these two things will help us optimize our time in future missions. We'll be flying a payload called Avatar, which stands for a Virtual Astronaut Tissue Analog Response. Basically, Avatar enables us to mimic individual astronaut organs, and Artemis II will mark the first time that these types of devices have been tested outside the Van Allen belts or away from the ISS. We will test if we can use these astronaut avatars as tools for measuring and predicting our human response to the deep space stressors. To evaluate this, scientists will compare Avatar data with space station findings we've already collected, as well as with samples taken from our crew both before and after the flight. For NASA, Avatar could help inform measures to ensure crew health on future deep space missions, including personalizing medical kits for each astronaut. For citizens here on Earth, it could lead to advancements in individualized treatments for diseases such as cancer. We'll also be flying an activity called Archer, Artemis Research for Crew Health and Readiness. For the Archer study, crew members will wear movement and sleep monitors called actigraphy devices before, during, and after the mission. These wristband monitors will enable us to study real-time health and behavioral information for the crew members and help scientists study how crew members' sleep and activity patterns are affected and how overall health and performance is affected. The study will evaluate how our crew members perform individually, as a team throughout the mission, including how easily they can move around within the confined space of their capsule. We'll also measure a set of immune biomarkers. For the immune biomarker study, crew members will supply saliva samples through the flight, and they have done so on Earth and will do so when they return for comparison. Scientists will gain insights into how the astronauts' immune systems are affected by the increased stressors of the radiation environment, isolation, and distance away from Earth during deep space flights. We'll also extend a set of ISS activities to the moon called Spaceflight Standard Measures. Astronauts will collect a set of measurements spanning multiple physiological systems to provide a comprehensive snapshot of how spaceflight affects the human body. We will conduct also physiological assessments, including testing their head, eye, and body movements before, during, and after the spaceflight, and that will be compared with blood samples that are taken before and after the flight as well. As soon as possible after landing, the crew members participate in basically an obstacle course to see how quickly they can function soon after going through a gravity transition. A few days later, they'll conduct a simulated spacewalk, and we'll do various tasks in a pressurized spacesuit again to investigate how quickly, again, they can adapt to that change in gravity. That prepares us for landing on the moon and eventually down the road going to destinations such as Mars. During the flight, we will make measurements with a suite of radiation sensors. You may remember that we've did something similar during Artemis I. Crew members will keep detectors in their pockets of their suits so that we can measure their individual exposure in real time during the flight. 2 other sets of sensors will also be placed in Orion. One will monitor radiation at different shielding locations in the spacecraft so that we can gain a better understanding of what the radiation protection does for our crew members on board. We will also be partnering with the Germany Aerospace Agency, or DLR, to provide sensors similar to what they provided during Artemis I. And the crew will deploy these around the Orion, again, to give us a comprehensive view of that radiation environment. Last but not least, a very exciting aspect to it is the ability to observe the moon. So you've heard a little bit about that already, and if we could cue up our first image here. Our crew will take time to observe the moon as they pass around the far side of the moon. Far side is the side of the moon that we never see from here on Earth. The moon will look about like holding a basketball at arm's length to them from the Orion. And if we could cue up the second image as well now, just to give another look here. Depending on when the mission launches and the final flight path, it's possible they'll see parts of the moon that have never been viewed by human eyes. All of the Apollo missions launched for the landing to occur in the early lunar morning. A lunar day includes 14 days of sunlight, 14 days of darkness. So basically, the crew that were flying around the moon all saw the same lighting conditions. So this could be a very unique opportunity to see the moon. We'll be asking them to look for things like albedo differences, variations in the grayscale that human eyes really can detect.
Albedo is how much light shines off the surface, guys.
Communicating back to the Earth, our science support teams will conduct their own test flight of a sort here on the ground, testing out how our support teams work to make sure that we can best support them when they actually go land on the moon during Artemis III and beyond. One last piece to our Artemis II science activities includes the deployment of 4 international CubeSats. Could we go ahead and cue up that image? Artemis II mission has provided us with the opportunity to deploy 4 CubeSats. Those are basically shoebox-sized payloads that essentially act as their own spacecraft once we deploy them. Our partners in Argentina, Germany, Korea, and Saudi Arabia are all partnering with NASA to take advantage of the opportunity that we have with Artemis to fly their own CubeSats. Each has its own objectives, but in general, all of the CubeSats are conducting complementary space weather measurements to the types of research that NASA's doing. So we're excited to provide this opportunity to our partners as we lead the way in space exploration and exploration of the moon. So real quick to conclude here, our integrated research campaign for Artemis II builds upon what we learned in Artemis I, and it sets the stage for successful exploration of the moon and ultimately onto Mars. Our campaign will help us understand the space weather that we'll face during future lunar missions, how to observe the moon and communicate with the support teams here on Earth, and in general, how we will react to, survive, and thrive in that deep space environment. Therefore, I like to say that Artemis II science is the science of us. Artemis II science is the science of humankind and how we'll act as we continue to press the boundaries and explore in deep space. Thank you very much. Back to you, Rachel.
All right, we'll go ahead and take questions. For those on the phone, you can get into the question queue by pressing *1. We will go around here into the room first. Please wait for the mic. And let's start here with Marcia Dunn.
All right, here's the fun part.
Hello, Marcia Dunn, Associated Press for Charlie. Given a fueling test on or around February 2nd, that is really tight by NASA standards to have a fueling tank test and then go right into a launch. Is the beginning of the February window even feasible given a February 2 launch, tanking test? And how perfectly does that test have to go for you to make any days in the February window?
We need to get through wet dress. We need to see what lessons that we learn as a result of that, and that will ultimately lay out our path toward launch. With a wet dress that is without significant issues, if everything goes to plan, then certainly there are opportunities within February that could be achievable. Yeah.
Just quickly, are you already just hoping to get to the end of the window at this point, or are the first few days of the window even possible at this point?
I think wet dress is really the driver to that, and how it goes. It would be hard to say that you could not. I mean, we do the wet dress early in February. You're going to need a little bit of time to go look at the data, but certainly it will be the driver toward LP17 opportunities.
Okay, we'll go behind to Bill Harwood.
Yeah, hi guys. Bill Harwood with CBS News. Two quick ones. One for Jeff. I realize you guys don't have launch dates yet, like Charlie was talking about, but there's at least a chance that you could be launching Crew 12 while the Artemis II mission is underway. Is there a minimum separation you would like to see between one launch and the other? What are some of the issues you have to deal with as you've got simultaneous missions? And maybe for John, on the outside, we don't have the insights you guys have, but this whole point about counting down to this huge launch with Artemis II and then Crew 12, I mean, it almost seems like there's a rush. People that aren't involved in what you guys do might think, well, why is there such a big rush when you've got this other mission you got to get to the space station? And doesn't that kind of reflect some of the lessons from the Challenger Commission and CABE about being in a hurry to get flights off? And why is this case different from that, if that makes any sense? Thanks.
So I'll take a start. I will say this is not a rush, and I actually take quite an issue with you.
Brother, don't invoke Challenger here, man. What, bro? Read the freaking room. What are you doing?
They mentioned we're working towards wet dress. I know the agency's preparing to launch Crew 12. There's a lot of preparation going on, but there absolutely are constraints, right? We have the TDRS network to work through. We have the various launch pads. The missions, right? It's not prudent for us to put both of those up at the same time, but we also have to ensure that both of them are ready to go. Because you guys have been in the space business long enough to know that we may run into an issue, and the last thing we want to do is make a decision too early and then lose an opportunity, right? That would not be responsible of us. So we need to keep pressing with both missions. We need to ensure we're doing that at the right speed and we're looking at the right technical constraints. And then, as we get closer, either the decision will come about because the hardware's talking to us and we have something that we need to go deal with, or we'll have to pick one. But that doesn't mean we should stop preparing for either mission right now, but we need to do that at the right pace.
Let me address the second part to Bill's question. Bill, part of my job as the MMT chair is to just watch out for what you just said. We go through numerous training simulations with Charlie and her team, with Jeff and his team. And I think I've got a good eye for launch fever. And I think I've used that probably more than I would like to during some of these simulations, because I sense that some of the team needs to take it as a learning opportunity. So with that said, the agency's looking at when to launch the next crew to station, and we're going to do our job to be ready to go fly. And I'll reiterate what I said in my opening remarks. I'm not going to tell the agency that I'm ready to go fly until I think we're ready to go fly.
Based.
Now, it's not totally my decision, but I'll have an input up through my boss.
Okay, we'll go here in the front.
For John and Charlie, I'm James from Channel 6, our local reporter. So, building off of Marcia's question, Artemis 1 took 8 months from rollout to launch. So could you talk about the lessons you learned the first time through this process that makes you confident that February could be feasible?
I can certainly talk about the lessons that we learned during Artemis 1 launch campaign, wet dress and launch campaign. One of the things that we learned and we worked our way through was, first off, it was a brand new vehicle. And so, as you know, we had some challenges through the wet dress, first with the LOX loading and making sure that we had the loading CONOPS that we started with and the one that we ended up with were slightly different, right? And that had to do with the
ConOps or concept of operations.
Amount of legacy hardware, and we found that as we regulated the LOX pump, as an example, in our first 2 wet dresses, that if you think about having a single stage and an upper stage, and you have that piping that goes up the tower, as you regulated that pump and it slowed down, you would get some warm LOX that would fall into that fill stream of the core stage, and so we had some trouble getting to the right inlet temperatures there. Took us a couple of tries to figure that out. Then during wet dress 3, we had some issues with some hydrogen leaks, right? Hydrogen leaks. So we worked our way through that. We made some modifications to our ground plates. We changed our the way in which we loaded hydrogen, and we got through our wet dress campaign, and then we had a issue with the replenish valve on the launch attempt number 3, where we finally launched, right? We sent a red crew out to the pad and we worked our way through that. So if I were to kind of step back from that and say, what's that biggest lesson that you learned? Well, the first one is on the LOX side of things, we learned how to load. We learned how to change our ConOps for that. We're utilizing the same ConOps. Once we made those changes and we worked our way through launch countdown attempt number 1, and number 3, we used that same philosophy and ConOps for Artemis 1. It worked successfully, and that's what we plan to use again. So that was a big lesson learned. The other lesson learned on the hydrogen side of things, we made some changes to that interface between the flight plate and the ground plate. We made some changes during our Artemis 1 campaign to improve that so that we did not have leaks where you have the flex hoses and the connections on the back of the plate. We saw very good performance during the launch countdown number 3. For that, the interface between what we call the cavity, where those plates come together, we saw some hydrogen leaks there. We learned that the way in which we loaded and the flow rates, the temperatures, the pressures have a whole lot to do with the leakage that we saw within the cavity. And so we modified that, and we were able to manage that through launch countdown number 3. We had the issue with the replenish valve. We went in and we made a modification post Artemis 1 to that valve, and we tested it with cryos for the replenish time frame with as many cycles as we would expect to have during Artemis 2. So why do we think that we'll be successful in Artemis 2? It's the lessons that we learned, right? Artemis 1 was a test flight, and we learned a lot during that campaign getting to launch. And the things that we learned relative to how to go load this vehicle, how to load LOX, how to load hydrogen, have all been rolled in to the way in which we intend to load the Artemis 2 vehicle. Now, what's new, right, for Artemis 2? Well, Orion's got some new systems on board. They've got a new ECLS system. We've got the crew interface piece of this, and we
ECLS is life support
to ensure that they're not influenced by the cryogenic environment of tanking, but they are used in day of launch, and they have to be used in accordance with our launch countdown and that critical timing. And so we've gone through and we've done a countdown demonstration test. We did a suited crew test before we even got to the VAB. And so we've taken this incremental approach to the testing for the new systems. And so I believe that we'll be ready for wet dress. Again, we'll see. This is our second hardware build for the core stage, so we'll see how it performs. We don't have the benefit of a green run, but we believe all of the lessons that we've learned from Artemis 1, we have used that countdown and that philosophy as our building blocks for Artemis 2.
Okay, we'll actually go to a couple of questions from the phone. We'll start with Lauren Grush of Bloomberg.
Hi, thank you so much for taking my question. I'm just wondering if you can maybe walk us through the major technical checkouts that will need to take place once you get to the launch pad ahead of the wet dress rehearsal. And is there anything that you're keeping an eye on that you think could have a significant impact on the schedule, or is everything moving as smoothly as you'd like leading up to now?
So I'll take that one. The things that happen once we get to the pad. One of the first things that happens after we get to the pad, we get connected, is we'll do some crew access arm swings. That is about a day or so after we get there. Of course, the first part after we get to the pad is just getting all the connections, all the validations, getting tied back to the firing room, getting ready to power up the individual elements. And so that is something that, you never want to say that's something that is routine, because you can have hardware that fails at any time. But I would say that's something that we did a number of times through Artemis I. There are not substantial changes to that. We will get into our crew module work. There is some unique work that we did not have to do during Artemis I because we didn't have all of the crew systems. We have late stow. We have other things that we have to do. We're going to power everything up. All the elements. We'll get into pad PSET. Mostly RF testing there. We've tested all these systems in the vehicle assembly building, but it's not in the RF environment of the pad. And so we'll go through and we'll do all of that checkout. We load the boosters. Again, there's some weather dependencies there, so we'll certainly keep an eye on the weather. Luckily, we're not trying to do it in the summertime when you have lots of thunderstorms, so makes it a little bit easier this time of year. There's nothing in particular through the whole pad flow that I would look at and say, this is the thing that is the driver to wet dress, right? All of the work has to get done. We have incrementally tested all of this offline or in the integrated environment of the VAB, and now it's just getting out to the pad and testing those pad interfaces, that launch pad environment with the RF. Wet dress is the big test at the pad. That's the one to keep an eye on. I guess if you're watching one and you say which one is the driver, that's the driver to launch. So that's the one to watch until we get to launch day.
Okay, we'll take another question from the phone, and then we'll come back here into the room. Next, we have Jackie Waddles with CNN.
Hi, folks. Thanks so much for doing this. So question for Mr. Honeycutt on the heat shield. I was curious, do you expect the heat shield to play a big role in flight readiness review or this risk assessment? Where do you personally stand on that? And then kind of on that line of thinking, just for clarity, who exactly is giving the final go for launch? Like, does this need to be a unanimous decision within the MMT, or do Jared or Amit have final say? Just some insight into that process would be wonderful. Thanks so much.
Yeah, so for the second question, Charlie does her poll, and I'm part of that poll. So I'm a small piece of that, and I do not have to have consensus from the MMT to make my decision relative to giving her my go or no go. I would like to have consensus. I'll tell you, a lot of times in our sims, we have complicated problems that aren't black or white, and so we do have varied opinions across the team. But at the end of the day, it's up to me to manage the decision that we make and send it forward to Charlie. Relative to the heat shield, we started that work back when I had my old job, before I got this job, and so I was paying attention to it then, but even more so now. We're changing, and I'm going to pass it to Jeff on this in just a minute. But just from my perspective, I think we've done the work, the analysis, and the testing to show that we're in good shape for the mission profile that Jeff and his team have planned. You want to add anything, Jeff?
So what I'll say is, through the testing that we've done after Artemis I and the work that we've done here on the ground, we understand the limitations of the heat shield on Artemis II, and it's incumbent upon us to fly within those limitations. So things that we've changed, right? We've changed the entry profile so that we're flying a profile that the heat shield can handle. And we're also ensuring that we launch on a day where the demands of the heat shield are lower. And so, really that turns into a range requirement to fly Not the 4,000 miles of entry that we flew on Artemis 1, but the 1,775 miles of entry that we're flying on Artemis 2. And so, the heat shield, yes, we understand there's some limitations with it, and so from a mission design perspective, we're making sure that we fly within those limitations, and that's how we're going to keep the crew safe. We're going to make sure that we're staying within the bounds of the hardware, and I think as John mentioned, the heat shield is being I don't want to say redesigned, but it's being updated for Artemis 3 to try and get back to that longer range requirement. That we'll be able to meet for those future Artemis missions. But for Artemis 2, of course, we've got that lower range, which is why we have fewer launch opportunities. That we're making Charlie's life a little bit harder by not having as many days we can launch on. But that's the right thing to do to keep our crew safe.
Okay, let's go here to Irene. Thanks very much. Irene Klotz with Aviation Week in Space Technology. For Jeff and then also for John, obviously you hope to not test the launch abort system, but in case it is needed, could you kind of run through some of those scenarios and what you've trained for, what is kind of possible, what is still like areas that perhaps are not covered? And for John, what's the overall risk for this mission for the crew, and is it that risk still more for launch, or at this point is reentry equal or greater risk? Thanks.
I'll answer the second part now. Anytime you got this much energy that you're putting into a system like this, and a lot of dynamic events, there is some risk. It's our job to either understand those risks and make sure that we've mitigated those in a way that we feel comfortable with and we can execute the mission. As Jeff said, though, this is a first time with crew. There's been some. We're flying a lot of new pieces to the configuration this time. Team, all that's gone through all the reviews. All those need to work. Jeff and his team done an outstanding job developing flight rules that give us the ability to respond quickly to any kind of off-nominal situations once we leave the launch pad and then get into the mission. And then, as Jeff mentioned a minute ago, the dynamic event of hitting the entry interface and then coming back into the Earth's atmosphere is obviously one that's where you put a lot more energy into the system. So, I would say I don't prioritize either one of those over the other one, but from an overall perspective, that's just part of cheating gravity. Jeff.
So as far as launch aborts, right, we've got abort coverage, from pre-launch there when the capsule's on the pad, all the way through, core stage flight. If we were to have an issue, and obviously you're right, we don't want to have one, but if we did have one that would require the crew to take the last abort, that is an option to them the whole way through until we jettison the last. After we jettison the last, at that point,
launch abort system.
We still have aborts where Orion would separate from the ICPS and then use the Orion engines actually to perform the aborts off of the core stage. And so it's really set up such that they always have an abort option. It's going to be a fair amount of G's. If they have to ride the last, of course, the boosters will still be burning at that point when the last engines ignite and pull the Orion off the top. But it's a case where the crew will survive and we'll get them home, and we'll be able to go on and get them home safe.
Take one in the back.
I feel the excitement too. It's a great day. Greg Redfern with WTOP Radio up in Washington, D.C. Two questions. One, if you can't make this launch window by April, when would be the next one? And the second one, a little lunar science. You're shooting for a lunar full phase on the far side, but what would be your limit if you can't make that as to the lunar illumination that you'd like? Thank you very much. And light that candle.
Yeah. All right.
For the lunar science, I'll say that the lighting conditions on the far side of the moon are not going to be criteria for determining when we launch. So what we have done is make sure that the astronauts are trained to provide us with observations regardless of the lighting environment. Now, I will say they have probably pretty much looked through what the options might look like, and they probably have their favorite. But again, we're going to launch when it's safe and we're ready, and we're going to do the best science that we can under those conditions.
All right, and so with respect to launch periods, rolling out, when we roll out, as you know, we do not have full access to everything at the pad. But one of the new capabilities that we did add for Artemis II is something called contingency pad access. And what that allows us to do is to go in and do a retest. It's an abbreviated retest of the flight termination system, and that plays into that 28 and 35-day requirement that we have with the range. So unlike Artemis I, where we rolled out and we had a single month of opportunity and you had to come back to the VAB to retest the FTS system, we actually have a new capability for Artemis II that allows us to stay out at the pad for 2 launch periods. So we can retest that, and you get 2 launch periods when you go out. Now, that is saying that if you don't have some issue come up that you require rollback for. So that would get us through 2 launch periods. You know, there is it's a bit of a puzzle, I would say, in terms of, you know, it depends on why you scrubbed, what kind of, you know, what you need to repair, and if you choose to roll back, and then what that turnaround time is. But we roughly, to answer your question, we have opportunities in just about every month. It does vary. The number of days varies by monthly opportunity, but it's roughly somewhere in a little less than a week. Some months it's a little less than that, maybe 3-4 days, but we do have we have opportunities every month.
Okay, we have time for just one more question here. Yes, you. Yes, you. Yeah.
Hi, Josh Dinner, Space.com. Barring any major malfunctions or mishaps, what milestones during Artemis II must go right in order to greenlight Artemis III to proceed as the program's first lunar landing mission?
Everything. Like, yeah, all of it, ideally.
Well, certainly, I would think we're going to have we'll have some things that we have to deal with, and we'll have to evaluate those and maybe do some course correction for Artemis III. But, you know, in my opinion, doing the checkout of the systems with the crew on board and getting the crew home safely, that's the big milestone.
Are there any mission components like proximity operations where maybe the Orion experiences a hiccup but still is qualified for that sort of maneuverability?
You know, specific to proc stops, I think we have great confidence in our capability to model that. After all, you know, we fly other space vehicles in proc stops all the time. We're docking to ISS fairly regularly. So, you know, if we have an issue with proc stops, you know, that's something I think we'd have to understand why, right? What was the cause of the issue? And as John said, understand the hiccup. But I wouldn't say that would necessarily, you know, disqualify the systems. I think the understanding there is what's important for what occurred.
All right, and that's all we have time for today. I want to thank our participants for being here today. You can watch live views of Rollout starting tomorrow at 7 a.m. as the rocket and spacecraft roll out of the vehicle assembly building. That'll be at 7 a.m. And then at 9 a.m. Eastern, we will have an opportunity to hear from NASA Administrator Jared Isaacman, as well as the Artemis II crew. You can watch both on NASA's YouTube channel. And with that, thank you for joining us.
That was dumb. That was dumb. This is arguably the biggest. This is arguably the biggest mission that NASA has flown since, I don't know, maybe the Hubble servicing missions, like STS. What is that? STS 125. And you do 30 minutes of Q&A, like 6 questions. No, sorry. Look, if if you were pressed on time, you should have done you should have done this earlier in the day. And I'm not just saying that because Sawyer didn't ask a question. This is a high profile mission. It's an extremely high profile mission. There should be a lot of press Q&A. The fact that there was like 7 questions is a little unacceptable. Yeah, I don't like that. That was dumb. Like, how long was the freaking Q&A? The Q&A was 30 minutes. Most of the questions were a bit silly. Do you really want more of that? No. Well, the problem is that I want space flight now and NASA space flight. The people who are here for every goddamn press conference, asking these questions. Why should the phone bridge get rewarded with a bunch of questions? Like they were on the phone, like 4 people asked questions in the room. There was like 30 credited press there, 4 people. Marcia Dunn, Bill Harwood, Irene Klotz, the guy from the radio. Who else? There's the guy from the local affiliate, and then so 6. 6 people. There's 30 people in the room ready to ask questions. Nah, that Q&A should be another hour at least. Do you think tomorrow's press conference will be more extensive? Probably. What about the bucket? Is it full? Yeah. The local dude was fine. Yeah. Yeah, that's... Why do you think it was so short? Don't know. I don't know. Because honestly, it's probably because they have to start getting to work to prepare. They have to start working to prepare for rollout. It's not like everybody down at Kennedy Space Center is going to wake up tomorrow morning at like 5 and just, commute to work, get there at 6:30, right? And then, okay, we've been here for 30 minutes. Let's roll out. The rollout campaign takes time. It takes time. They're probably going to be up all night. Yeah. The CBS guy, dude. Look, man. There are times to talk about risk in spaceflight, and I don't think that this press conference is necessarily not the right venue for that. That certainly is the right question to ask, but invoking the Challenger Accident Investigation Board because there's a potential schedule conflict with Crew 12 was... Bro, read the friggin' room, dude. What are you doing? Why would you even bring that up? That's just... Dude, that is... Bro, come on. Think about what you're asking. Like, Charlie Blackwell Thompson, she was a launch director during the shuttle program. I'm fairly confident she was a launch director in the shuttle program when Columbia happened. She's been there for a while. Like, brother, read the goddamn room. What the hell is the matter with you? Why would you ask? Why would you even bring that up? It's so bad. And for a scheduling conflict with Crew 12? And then somehow invoking that's Go Fever? Brother, that's not Go Fever. You don't... I'm sorry, that question pissed me off. I was like, what are you doing? Stop it. Why would you even go there? Yeah, Joe, that's what I'm wondering about. Bill Harwood usually asks really good questions. What the heck was that about? Who pissed in your cornflakes this morning, dude? He's from CBS, dude. He's not. They'll ask him more questions. They'll listen to more of his questions. Stupid. Why would you even go there? Why would you even bring that up? You think these people don't understand the risk? Most of them were there when we lost 7 astronauts in 2003. I'm just saying. Anyway, sorry, that really grinds my gears, dude. You muted the response, but right before you did, the panel member was saying, and I take offense to that. He did. Who did? John Honeycutt? Let me see it again. Sorry, I had to get my piece in there. I'm sorry, I couldn't shut up. That was here. Let's listen to that again.
You guys have, but this whole point about counting down to this.
Okay, we'll go behind to Bill Harwood.
Bill Harwood with CBS News. Two quick ones. One for Jeff. I realize you guys don't have launch dates yet, like Charlie was talking about, but there's at least a chance
Jeff did
that you could be launching Crew 12 while the Artemis II mission is underway.
Yeah.
Is there a minimum separation you would like to see between one launch and the other? What are some of the issues you have to deal with as you've got simultaneous missions? And maybe for John, on the outside, we don't have the insights you guys have, but this whole point about counting down to this huge launch with Artemis II and then Crew 12, I mean, it almost seems like there's a rush. People that aren't involved in what you guys do might think, well, why is there such a big rush when you've got this other mission you got to get to the space station? And doesn't that kind of reflect some of the lessons from the Challenger Commission and CABE about being in a hurry to get flights off? And why is this case different from that, if that makes any sense? Thanks.
So I'll take a start. I will say this is not a rush, and I actually take quite an issue with you using that word. That's not where we're at right now, right? We are
freaking Jeff, dude. Yeah, that is not, bro. You're not even close. You're not even. Do you even follow the space program? Like, bro, do you even lift? Like, that's not the same thing at all. This is not even close to go here. Oh my God. Why would you even ask that? Yeah, okay, cool. Jeff was like, look at him. He's like, are you kidding me right now?
I will say this is not a rush, and I actually take quite an issue with you using that word. That's not where we're at right now, right? We are preparing to launch Artemis II. As Charlie mentioned, we're working towards wet dress. I know the agency's preparing to launch Crew 12. There's a lot of preparation going on, but there absolutely are constraints, right? We have the TDRS network to work through. We have the various launch pads. The missions, right? It's not prudent for us to put both of those up at the same time, but we also have to ensure that both of them are ready to go. Because you guys have been in the space business long enough to know that we may run into an issue. And the last thing we want to do is make a decision too early and then lose an opportunity, right? That would not be responsible of us. So we need to keep pressing with both missions. We need to ensure we're doing that at the right speed and we're looking at the right technical constraints. And then, as we get closer, either the decision will come about because the hardware's talking to us and we have something that we need to go deal with, or we'll have to pick one. But that doesn't mean we should stop preparing for either mission right now, but we need to do that at the right pace.
Yeah, that's so screwed up. That's so screwed up. Why would you even go there? What the hell? Read the room, dude. Hey, come on. I'm sorry. That pissed me off, and I wasn't here. I wasn't even here when Challenger. I wasn't even born yet. Guys, all right. You want to hear what Jeff won't say, and I don't speak for NASA. I don't speak for them. You want to hear the real truth to that question? Look, you press forward with Crew 12. You press forward with Artemis II. If it was me, Artemis II would take priority because of the difficult phasing operations for that mission. All right? Artemis II has to launch with the right recovery conditions, the right reentry conditions, it has to launch with the moon being in the right phase. That's really important. So compare that to the ISS, okay? The ISS phasing opportunities come literally every 90, well, not every 90 minutes. I'd say every 6 hours, okay? It's a lot more flexible. The short answer to this question is that the ISS is way closer than the moon. It's like if you were going to plan a road trip from California to Texas, right? Versus, living in California and going to the damn grocery store, okay? The grocery store ain't going anywhere. It's right there. Your big road trip, you probably plan getting provisions and groceries for your road trip around that. You know what I mean? And also, Crew 12 is on a Falcon 9. Falcon 9's easily recyclable. It can do 24-hour recycles, no problem. No problem. This isn't even go fever. There's a lot of flexibility in Crew 12's launch campaign because the ISS is closer. There's plenty more opportunities during the day, during the night, whenever the ISS passes over Florida to be able to get to it. The moon, the right phasing and the right conditions for the mission, they only come around basically once a month. So that mission's probably going to take priority. You can get to the ISS pretty much any time. You can, as long as the ISS track goes over, as long as the ISS flies over Florida. And spoiler alert, it flies over Florida a lot, probably 2 times every day. I mean, if I'm thinking about orbital inclination and precession correctly. Space Pope, 100 bits. Smoked a balloon, 21 months. Yeah, that's why I like Jeff, Fluffy. He's a flight controller, dude. He's a flight controller. He's cut from Gene Kranz, Chris Kraft's cloth, dude. That's is the real deal. That's the kind of person you want running the mission. Somebody that's gonna be like, dude, shut up. What the hell's the matter with you? You need somebody to tell it like it is. That's why I like him. Every press conference that he's in, he does something like that where he's like, no, what are you talking about? In light of recent events, EJ, do you want to talk about the extra risk for a lunar mission? It's not lost on me that if there was a medical emergency on Artemis II while on the way to the moon, it's not like the ISS. It could take days to get back. 3 days at best. Binary. Dude, this is gonna sound like a non-answer, but the real right way to do this, all right? So a medical emergency. What type of medical emergency are we talking about here? Are we talking about something like what happened on the ISS, where some crew member had a health issue non-related to the mission and had to come home? Or are we talking about somebody getting hurt, like during a phase of the mission? What are we talking about here? Because if we're talking about the former, the best way to ensure that doesn't happen is to, okay, long story short, make sure your astronauts are healthy. Make sure they're healthy. That's all. That's it. Make sure they're healthy. Make sure they don't have underlying conditions. Doing a CAT scan for your 4 crew members, before you go up into launch is not something that's going to take up a lot of their time. One that would require an immediate return, which isn't an option. Dude, look, the mission does carry risk. Of course it carries risks, but retiring that risk through mitigation, i.e. making sure your 4 crew members are healthy, is really what's going to prevent these things from happening. With that being said, the worst time for something to happen in this mission would be post-translunar injection. Post-TLI, so basically where Apollo 13 had a problem, that would be the worst. When they go into a free return trajectory, that would probably be the worst time. However, once again, the Orion capsule, it's unlikely that they'll initiate TLI if they thought something was going to go wrong. We have the benefit of Apollo 13 for that exact issue, right? The other thing is that the Artemis II mission essentially goes to high Earth orbit before it does a translunar injection burn. So that Orion capsule is going to be up there for a couple of days floating around Earth, and then they'll use Orion's service module to do a translunar injection burn. capsule will already have been in space for a good amount of time. I think 3 to 4 days. Yeah, 3 to 4 days in space before that happens. So, believe me, they're going to be doing all kinds of checks to make sure that they're absolutely ready to go. Once again, you can't think... This is something that I encounter a lot, Binary, with a lot of questions that I answer about spaceflight and risk mitigation. The best way to mitigate risk is to make sure that it doesn't happen. Now, obviously, with a highly risky mission like this, you are going to have unknown unknowns. So this mission is carrying a lot of extra risk. I've talked about that. There are points in the mission where, look, you're not going to be able to get immediately home. Post-translunar injection, if something goes wrong, you're a week from coming back. At best, you're a week. That's a long time. Now, if there is a problem, and here's the important part. If there's a problem so severe that you enter into that kind of scenario, right? Obviously, there's an abort contingency procedure to come home. But this is what I mean. You can't think about spaceflight defensively like that. This is really important to understand from a risk perspective. You can't think defensively. You have to think offensively. Now, what does that mean? Look, Binary thinking, and once again, I'm not picking on you. I get asked this all the time, and I get questions phrased like this all the time, like people think defensively. And what do I mean by defensively? Oh, well, what if something happens during this phase of the mission? If something happens during this phase of the mission that would constitute an abort, you probably shouldn't have launched it. All right? And I suppose that that's what Bill Harwood was getting at with his question, but invoking Cabe is just... That is tabloid news tier. That's so fucked up. Excuse my language, sorry. It's so messed up. But you have to think about it offensively, all right? Not, what are we going to do if something goes wrong during this part of the mission? That you don't... Guys like Jeff don't think like that. You can't. You can't think like that. If you're playing a defensive game in space, you've already lost. Okay? You got to think about, what are we going to do to make sure that that does not happen during that phase of the mission? What do you do to make sure? Okay, so if an astronaut has a medical problem before translunar injection, or after translunar injection, why? The only time you'd have some type of medical issue at that phase in the mission is if A, something goes catastrophically wrong with the capsule, right? And B, if somebody has a medical emergency like what happened with Crew 11, all right? So 2 ways to do that. 1, make sure your astronauts are healthy. 2, make sure the capsule can take it. Make sure the capsule can do this phase of the mission. That is why Artemis II at the beginning of the mission is going to do a shakedown in medium Earth orbit. They're going to do a shakedown out there to make sure that everything is good to go. That's a complementary phase of the mission. Doing that first part of the mission, right, where they're hanging around in low Earth orbit, doing the rendezvous proximity operations with the second stage or the third stage, is to make sure that you're going to maximize your chance of success. That's offensive thinking. All right, you don't think in mitigations with spaceflight. That's how you get someone killed. Can't think defensively. You have to think offensively. What are we going to do to prevent this from happening? If something is going to go wrong, like an Apollo 13 style event, you probably shouldn't have launched. And once again, we have the benefit of hindsight knowing that because of Apollo 13. Because of missions like, I hate bringing it up, especially Challenger. But Challenger was Go Fever, which is not exactly what this is. This is a high-risk mission. Make no mistake, fellas. It's a high-risk mission. This is dangerous. This is a very dangerous mission. So, what do? Is NASA going to sit there and be like, well, it's a dangerous mission, let's launch it anyway? No. What are we going to do to try and make it less dangerous? That's what I mean about mitigating risk. That's what I mean about offensive thinking. You can't think defensively with spaceflight. You'll get somebody killed. I have a solution. They should each travel with an emotional support animal. I mean, Bacon, humanity did launch a dog into space in the early 1960s, and it didn't end well. It didn't end well. The Soviet Union did that. It did not end well. We should probably not do that. Maybe a stuffed animal. Stuffed animal would be better. 0G indicator. What happened to the dog? Laika went to doggo heaven. Laika was a good girl. She's a good dog. She's a good doggo. They're all good dogs. Serious question. If Artemis II scrubs like Artemis I and it doesn't end up launching before May, would that put ladder missions at risk? As HLSs are supposed to have a 90-day loiter period. So sad. That's a good question. Let's think about that question offensively. Okay? Don't think about like, oh, what if something goes wrong during the mission? Okay. So, you know that SLS is designed to support a type of architecture that depends on other launch vehicles at this point. That is going to change the way you look at risk with launch campaigns, is it not? Right? Okay, so
Discovery, go at throttle.
Because SLS and Orion are now contingent on the landers being out there and Gateway being out there for what it's worth, all right? You're going to change. You're basically you're entering into a style of thinking that's going to basically maximize your chance of success per launch campaign. And you're going to design your concept of operations or con ops around an expedient launch. Okay? Now, does that mean go fever? Hell no, it doesn't mean go fever. No. You're going to design your concept. Charlie Blacko Thompson was talking about this at the beginning of the press conference. Actually, it was when somebody asked about the FTS. They are designing SLS's launch campaigns nowadays to be able to make sure that you have minimal amount of delays on the pad. You're not good. It's highly unlikely you're going to see what happened with Artemis 1 with Artemis 2. Why is that? Because Artemis 1 happened. They know. They know. They know that the behavior. That's why it's important to launch uncrewed first, right? They know the behavior. They understand the behavior, especially with leaky hydrogen. So the hydrogen tail surface mast umbilical carrier plate, it developed a leak in the recirculation lines for hydrogen top off. When you fuel liquid hydrogen onto a booster, you need a vent line that leads to a purge flame. If you don't have that, hydrogen will leak somewhere and it'll blow up something that you don't want. So you give it a pilot light and a burner to burn off. Hey, Raven Guard, 69-month resub. So, because they know, like I said, think about it offensively. Because they know that SLS is going to be contingent on landers being there, and it has to be relatively expedient in its launch campaign, i.e. not a lot of scrubs, right? You're going to optimize your concept of operations and launch campaign around mitigating that. Make it less likely to happen. You can't have leaks. I mean, well, the truth with liquid hydrogen is that you can have leaks. You just have to control where the leaks are. That's why they have that recirculation line in the ground umbilical, or not a ground umbilical, tail surface mast umbilical carrier plate. I'd call it forward thinking, not so much offensive thinking. Yeah, exactly. Yeah, I mean, yeah, that's not really the right way to say it, Lunar Lander, but you understood the gist of what I'm saying. Like, you can't... Everybody thinks about it like it's a Hollywood movie. Like, oh, what if it blows up? What if it blows up? If it blows up during the launch, you probably shouldn't have launched it, right? There's no way that NASA doesn't know that. There's no way that guys like Jeff and Charlie Blackwell Thompson and John Honeycutt don't understand that. That's why they're up on the panel. That dude understands that. She understands that. Jeff understands that. I don't know about these two, but that guy was cool. He had a lot of cool things to say. She's the recovery officer, which is pretty sweet. Like, why? If you even had, like, think about it like this: if you have your hand on that button, and would you press it knowing that there's a good possibility it might blow up? Hell no, you wouldn't. Especially with people on board, not a chance. Not a freaking chance, dude. Not a freaking chance. With space flight, just take your time. Just take your time and be deliberate in what you do. It's that simple. There are ways to make sure that the rocket doesn't blow up. There are ways to make sure that that doesn't happen. The Artemis 1 flight campaign is a good example of this. And you can use that, and they're going to use that. They are using that to make sure. Now, they did change their con ops a little bit from Artemis 1 to Artemis 2, but that is a result of, once again, Artemis 2 is going to have a little bit of a different launch campaign than Artemis 1. The reason why is because Artemis 2 is centered around streamlining and optimizing these processes. You're not going to have 4 or 5 wet dress rehearsals with this core stage, guys. It's not going to happen. You're not, I'd say maybe 1 scrub, maybe, just because it's a complicated vehicle. At best, you're not going to see like 5 attempts to try and send the thing. That's not going to work that way, because they have the Artemis 1 mission as their analog. So about that heat shield, what's the story? Orion's, okay. On Artemis 1, Orion's Avcoat heat shield developed charring and spalling during reentry. It basically started to come apart during the reentry. The reason why this happened is because they were using blocked Avcoat ablator. Okay, so the Apollo program used a very similar ablation material. It's actually the same. It's called Avcoat. An ablator is something that burns off when exposed to compression heating from air compression during reentry. It burns off, and when it burns off, it takes some of that heat energy and disperses it, right? Think about a log in a campfire. Hokie, you know this already. I'm just saying it for everybody else. Think about, like, if you have a campfire, guys, you put the log in there, it burns off, right? It is that burning off is fuel for the fire, right? It's going to keep the fire burning, but eventually it's just going to disperse all that energy, right? The funny thing is that ablators are almost consistent with like charcoal, but that's another story. So Apollo was using a fiberglass honeycomb matrice with Avcoat injection. I have a picture of it. Let me get it. I swear I'm not making up words. Okay, so with the Apollo heat shield, they had a fiberglass honeycomb matrice, all right, like a matrix. This is an aluminum plate behind it. Okay, you could see these little lines right there. Okay, and you could see they're honeycomb shaped. If you like, I'm trying to describe what a fiberglass honeycomb matrice looks like. It looks like a beehive, basically. And instead of filling it up with honey, they fill it up with Avcoat. Okay? Now, Hokie, I'll speak in more nerd terms. Everybody, if there's some big words thrown around that you don't understand, let me know. Okay, so mechanically, Hokie, this stays together a lot better. There is charring and spalling, just like there is on Orion's heat shield. But with the Apollo heat shield, the fiberglass honeycomb matrice mechanically kept the thing really tight. It kept the ablator together. It was very unlikely that you'd get charring and spalling past a couple inches during reentry, because of the mechanical strength of the fiberglass holding everything together. Think about this like reinforced concrete. So this is your rebar, right? And the Avcoat is your concrete. It's way stronger mechanically. It holds everything together. So Apollo did have charring and spalling. You can see it right there. But it's not nearly as bad as Orion. With the Orion capsule, guys, some of the heat shield charred and spalled in a way that made it down to the aluminum heat sink. There is essentially, guys, behind on Orion and on the Apollo capsule, there's an aluminum lattice behind it that is basically, it's a heat sink. It's a heat sink like what you'd see on a computer. It's designed to tank any heat that gets through, any thermal transfer that gets through your ablator. It does happen, okay? On the Orion capsule, like if you look here at this ablator, right? This is the Apollo's heat shield. It maybe got an inch down through the ablator, but you could see the fiberglass held it all together. See the fiberglass honeycomb? Some parts it didn't char and spall at all. It was perfect. That's uniform ablation right there, okay? But you can see there's still chunks missing. It does happen. Right, but the fiberglass held everything together, and the ablation the spalling didn't go further than an inch down, maybe at best. On Orion, it went all the way down to here in certain areas. That's not good. Holes in the heat shield doesn't work very well. Now, why? Why does Orion have this problem? Starbase Live. Okay, so I'm going to get you some pictures here, and I'll show you why. I just got to open up the right stuff here. I should have probably had this stuff open, but it's K. Okay, so instead of the honeycomb lattice that the Apollo program used, Orion is using blocks of Avcoat. Now, if you think about it like this, your mechanical architecture with the Apollo is like reinforced concrete. With Orion, it is using the same material, but think about it like these are bricks. Like they're made in blocks, and they stack the blocks around. Now, this does have the aluminum backing plate behind it, just like Apollo did, right? But the problem basically boils down to this. If you're using a blocked Avcoat ablator for your heat shield, see the seams? There is an incredible amount of charring that happens in the seams right here. Basically, plasma starts to get in there. Superheated gases start to get in there, right? And are there any masons here? What happens if you have bricks, right? And water gets in between and erodes the what the heck is the thing that puts bricks together? What if water gets in there and erodes the it's not grout, Kickning, that's tiles. Is it called grout? Mortar, that's what it is. What happens if water goes in there and ablates and erodes the mortar away? The bricks will fall, right? Same idea. Plasma is getting in between the seams on Orion's heat shield. You want to see what it looked like after Artemis 1? Look. See? Look at that. Look at that discoloration. Look, that's not good. That discoloration, Avcoat doesn't burn like that. It burns black and white. What is that? What is all that in there? Look at an entire chunk's missing from that block. Look at the spalling that happened here. That's the problem. See all of it? Look at the seams, at the corner seams, gone. Almost down to the aluminum. That's not good. That's really bad. Look at that right there. So that is one of the mechanical connections to the Orion service adapter in the service module. Not the OSA. OSA is not the right thing. It's the service module. Look, look at all that. That's no good. Actually, no, that's not a connector piece. I'm not sure what that is. The connector piece is over there. But the more you look at this thing, look right there. That's bad. That's really bad. Now, I know what the next question is. People are going to ask, why the heck are you sending it? Look, that one's down to the aluminum. That's really bad. Why are they sending people on this if that's what's going on? Well, NASA, with the Orion capsule, they're flying a different reentry trajectory than Apollo. With Orion, they're basically skipping off the atmosphere, right? And then re-entering. The idea is that Orion's basically aerobraking first and then re-entering. Now, why are they doing that? Why are they doing this re-entry? I'll be honest with you, I'm not 100% sure why you would do this, why this is preferable. If I had to guess, it would probably be something to do with thermal flux in the heat shield. Basically, if you skip off the atmosphere, you have time for the heat shield to radiate some heat away, and then you do your reentry. So the total, it's probably a way to mitigate total flux of heat energy into the heat shield over time. Apollo didn't do that. Apollo didn't skip off the atmosphere so much as come down into the atmosphere, kind of level off, so to speak, and then come down. The reason why they didn't do a direct reentry is because they don't want to open up the crew capsule when it comes down and find liquid in there and not people. Yeah, they use it also to mitigate G-forces. Now, Orion on Artemis 1 used that skip trajectory. Motorcycle. It used that skip trajectory. And what happened is they dipped the heat shield in, it got really freaking hot, and then they skipped off the atmosphere, and basically the heat shield going off into microgravity and cooling basically caused all the cracks to form, basically. I mean, that's not the exact way to say it, guys. They basically skipped it and it got too hot. Plasma started permeating through the heat shield because of it started going through the seams of the Avcode ablator. Now, like what we see right here. And when it skipped, so these chunks, they started getting cracks, right? And it started going through. And then when the capsule skipped up off the atmosphere and went back out into space, any pieces that were stuck in here, right? Any pieces that were stuck, from reentry, the lack of G-forces basically made it come apart, and then they re-entered with a bunch of holes in their heat shield, and that made more holes. Their solution to this problem is just re-enter Orion with people on board for the first time, untested on Apollo's re-entry trajectory. Basically, dipping that heat shield down there and not so much skipping off the atmosphere, but leveling off the capsule during re-entry and then re-entering. That's the solution to make sure that, it's good. Now, to be very, very clear, that will cause charring and spalling again with this heat shield design. Absolutely. But NASA is confident. I don't want to say this out loud. NASA is confident that, if they stay there, it's going to crack the heat shield a little bit, not too much, right? If they stay in reentry and not skip out of the atmosphere, that it's going to keep the heat shield won't lose mechanical adhesion. It won't do it as much. Guys, look, I don't know more than NASA. I'll be 100% honest with you. In that press conference, Jeff said he's confident in the flight trajectory. I know he wouldn't say that. He wouldn't say that unless he was absolutely sure. He's a flight director. You don't screw around with that. He wouldn't say that, and he was absolutely sure. That heat shield absolutely will char and spall. So much so that they're redesigning it completely for Artemis 3. Like hot glass going into cold water. Mm-hmm. The entire idea seems to be to lower the accumulation of gases in the blocks over time. Yeah. Yeah. The problem is that, once again, see, Hellfish, this is what I don't like. All right. So, look, you don't have a good analog nominal test of this heat shield. I don't believe in putting people on it. And keep in mind, I'm an armchair rocket scientist, guys. I just cover space flight. Do I know more than NASA? Hell no. Probably not. They're probably right. They wouldn't send it unless they were sure. However, with all that being said, I wouldn't accept that. I wouldn't accept it. I would want that heat shield to work. I would want it to work. I would want a good analog test for the blocked heat shield to make sure absolutely that you mitigated the charring and spalling to a point that you are 100% sure that your crew is going to make it home. You are 100%. There's no way that heat shield is failing, right? This is what I mean about that offensive thinking again. I'd want a good analog test. Artemis 1 was not a good analog test because it didn't do what you wanted to do. It came apart. The heat shield delaminated. I don't know about you fellas, but I would not be okay with this. And I'm sure that NASA is. That's why they're redesigning the heat shield. However, the next flight has people on board. I don't like it. I don't like it. I'll go along with it, but I don't like it. This is unacceptable. That's unacceptable. I would not put people on this. What do I know, though? Maybe I'm just a bitch. Maybe NASA knows better than me. Probably. I really would hope so. I don't trust that. That changing the flight trajectory in my mind seems like defensive thinking. But not necessarily. It just look, they're redesigning the heat shield for Artemis 3 for this not to happen. Okay, that's cool. I'm fine with that. They're using this kind of version 1 of the blocked Avcode ablator heat shield, right, with people on board for the first time, and then they're going to redesign it again with people on board for the second time. That's not. I don't like that. I really don't. I don't like it. I'm not going to sit here. Don't get me wrong. I'll be cheering on the Artemis II mission, and we'll cover as much as we can cover, and I'll be cheering them on every step of the way. This is the first time that I've encountered something with spaceflight where I'm like, nope, don't like that. Nope, don't like that. I don't like it. It'll probably be okay. But that's the thing. This is the first time we're going back to the moon in over 50 years. This is an extremely high-profile mission. You want to send it on a probably? Are you freaking crazy? What's wrong with you? Well, not what's wrong with you. They know more than I do. I know that. Like, I'm sorry, dudes. I don't mean to be a Debbie Downer. I'm just saying what I think. I would not be satisfied with this. I would not be satisfied because you got to think about where my mind is coming from here. Is you got to think about what is the Orion capsule going to be doing 10 years from now? And I know somebody's going to crap post and be like, well, hopefully it's in a museum. Yeah, maybe you're right. But let's just say the Artemis program goes forward as planned and we get to like Artemis 20, Artemis 30, Artemis 32, right? To go send people out to our moon base or whatever, right? Say you get to that point. This thing is going to be flying a ton of missions. It's going to be flying a ton of missions. For a lunar capsule, the Orion capsule is built to be a long-term spaceflight vehicle for human exploration. That's the whole idea. You're going to be building a lot of these in the future. Okay? I don't know why NASA seems to be okay with, doing some analysis on a bad heat shield and figuring out that changing the flight trajectory is going to be okay so we can redesign it for the first crewed landing mission. Orion's going to be flying for hopefully for a long time. I would want that heat shield working perfectly before I put anybody on this thing. Like, that's not EJ's stupid rule, okay? That's NASA's own freaking rules. All right? NASA has a guidebook on basically how you should run your spaceflight program, and it says do the opposite of what they're doing. Now, once again, with spaceflight, you get curveballs. That happens. Stuff like this happens. But I really don't see why you would be comfortable with a changed flight trajectory here. The mission's already risky enough. You're sending people out to the moon. That's not an easy thing to do. This is already a complicated mission, dude. Why are we adding more complication to the complication? That's not that it's not like it gets mitigated because it's double the risk. That's not how that works. What did you make of Jared's justification on the heat shield decision? Like I said, 415, everybody at NASA seems to be okay with this. They seem to be all right with this, and I have to take that into my judgment as just an armchair rocket scientist, right? As opposed to an actual one. I have to take that into account. Look, Jared Isaacman understands the risks. He does. There's no way he doesn't understand how high of a profile mission this is. Right? And truth be told, that modified flight trajectory will probably be fine. Right? I'm not good with probably will be fine with heat shields. I'm sorry. I'm not good with that. I'm not okay with this. Like, what's up with the heat shield? Linus, look. This is the heat shield from the Artemis I Orion capsule. This is post re-entry, after the Artemis I mission. Would you want to fly on something that pokes holes in the heat shield? Nope. I also resub, but you've been on a roll. Thanks, Dons. I appreciate it, man. Thanks for all the resubs, guys. I appreciate you guys. Sorry, I really just, look, it'll probably be fine. But I'm not good with probably will be fine. That is an unacceptable amount of risk that I would be willing to accept for this mission. However, if everybody at NASA says it's fine, it's fine. Personally, I think a blocked Avcode ablator for trans-Earth injection lunar reentry trajectories is dumb, if you really want my honest opinion. That is my armchair rocket scientist opinion. I'm probably wrong. I think a blocked Avcode ablator is stupid. That's stupid. The reason why NASA went with a blocked Avcode ablator instead of just making a copy of the Apollo Command Service Module's heat shield, which we know works, the reason why they went with a blocked Avcode ablator because it's cheaper. The reason why it's cheaper is because they're already making blocked Avcode heat shields for Mars entry, descent, and landing. We already have the supply chains for a blocked Avcode ablator. The other benefit of a blocked heat shield like this is that you can do better quality assurance on it because you can inspect each individual block before you put it on the heat shield. So that was their rationale for switching to a blocked heat shield instead. For what it's worth, Dragon does use a blocked heat shield as well. It is not made out of Avcoat, though. It's phenolic impregnated carbon ablator. Think like charcoal submerged in resin. That's kind of the idea. Theirs works. But Dragon is only designed to come back from low Earth orbit. It's not designed to come back from the moon. This is a totally different ballgame. We're talking about a much higher peak heating and a much longer period of heating during reentry. The Dragon capsule, when it comes back down, is going, I don't know, at entry interface, it's probably close to like 19,000 miles an hour. When Orion for Artemis II comes back and lands, it's going to be going 25,000 miles an hour. It's a little bit faster. So you're going to need mechanically a different type of heat shield. Like I said, they didn't go with the honeycomb, the fiberglass honeycomb ablator because there was no supply chain for it. Do you know why there was no supply chain for it? Because we decided to stop going to the moon 50 years ago. That's why. So the funny thing about all this is, if you want some kind of an additional like postscript to this whole EJ rant, the funny thing about this is that the first Orion analog to fly on the Exploration Flight Test 1, the EFT-1 mission, right, in 2014, which was an Orion with a heat shield on it, launched on a Delta IV Heavy. That Orion had a copy of Apollo's heat shield. The first Orion capsule to ever fly through the air had a direct copy. A honeycomb, a fiberglass matrice honeycomb Avcode injected heat shield. It had that. It had something very similar to Apollo. And it worked great. But NASA decided that that would take too long. And after the EFT-1 flight, which was supposed to qualify your heat shield, they redesigned the entire thing to a blocked Avcode heat shield because it's easier to quality test it. And we didn't have the supply chain to make another Apollo. They made the heat shields by hand during Apollo. So they made the heat shields by hand with Orion. And then just deemed that was too hard to do. I understand NASA's rationale. I think that's dumb. What do I know? I'm just a guy. I don't know. I could be wrong. I probably am. But I'm not going to sit here and say, oh yeah, it'll be fine. I'm noticing some serious red flags here with your concept of operations, with how you're going about testing this heat shield. Why don't NASA do more frequent test flights like SpaceX does? You know what, Veljex? That's a really good question. Orion, when it was the crew exploration vehicle, Orion was supposed to launch on Ares 1. And I know some people don't like the Ares 1 launch vehicle. Some people do. I personally think it's super cool. I get it, vibration issues, etc., etc. What Orion was originally supposed to do was replace the space shuttle for ISS rotation missions to bridge the stopgap for a commercial. Basically, what NASA wanted to do in the late 2000s is start sending Orion to the space station to have crew rotations, to test the Orion capsule, to test long-duration missions for the capsule in space, and to test the heat shield. This would have made it so you could build the supply chain, because you need Orions for the ISS, you could build the supply chain out for the heat shield. So when it came time to actually go to the moon, right, in the 2020s, and when commercial started to pick up the slack in the 2020s, they would have a good, well-qualified, and well-understood capsule. In 2011, we decided we didn't want to do all that because it was too expensive. Enter the rationale for flying and redesigning the heat shield pretty much every time it flies. So think about it. After EFT-1, they redesigned the heat shield. After Artemis 1, they didn't redesign the heat shield because the Artemis II heat shield was already made, so they changed the flight trajectory. Artemis 3 redesigned the heat shield. That's not good testing. That's really, really bad testing, if you really want my honest opinion. That's really bad. But, like I said, I'm going to say my piece. I will not bring this up again throughout the entire rest of the Artemis II launch campaign, and I will be cheering them on every step of the way. I think that's dumb. I'm probably wrong. What do I know? Anyway, what's up, dudes? It's probably due to them accepting that a few astronauts losing their lives is an acceptable loss. Not saying I agree. No, I don't think so. Veljex hit the nail on the head, dude. He hit the nail on the head. Why don't they test this more? Well, they can't. Orion's only supposed to only can launch on SLS because we canceled Ares 1, the thing that would have tested the heat shield more. Because we wanted to save money or something, whatever that means. I don't know what that. The government says they wanted to spend money, and that was their justification for getting rid of Ares 1. Like, be real, fellas. You guys ain't in the business of saving money. That's not what you do. Shut up. Don't lie to us. Well, It's a tall ask, I guess. But anyway, Cats, that's the thing. We are trying to plan for a space program that requires hardware-rich mission architecture, meaning a lot of rockets. And we don't have a lot of rockets. That's really it. I don't think that they're willing to accept the risk of the astronauts' lives. This is most certainly a risky mission, and this is a risky business. But if you don't do your due diligence, the risk factor goes up exponentially. And I'm not saying that NASA isn't doing their due diligence. I think they don't have a choice, if you really want my honest opinion. I don't think they have a choice. What are you going to do? Launch this uncrewed? I mean, if you wanted my opinion, that's what I would do. I would launch this uncrewed. And I would do another Artemis 1. But the problem is that you only have 3 SLS Block 1s, Artemis 1, 2, and 3. You only have enough upper stages to do 2 more missions with this current version of SLS before you have to go design another upper stage, the exploration upper stage, which is scheduled to fly on Artemis 4, which should be sometime in the late 2020s, like 3 or 4 years from now. If you really want my honest-to-God opinion, launch this without people. Yep, launch it without people. And then do with Artemis 3 what you would be doing with Artemis 2, or the Artemis 3 stack, and then Artemis 4, have Artemis 4 be the first landing. They won't do that, but that's what I would do. I don't trust it. Redesign the heat shield. Yeah. So what? It's going to take another year? That's fine. You'll have more rockets by then, because the Artemis 4 stack with the exploration upper stage should be finished by then. You know what I mean? I don't like it. I don't like it. It's just, it reeks of risk mitigation, or not risk mitigation. It reeks that defensive thinking I was talking about. But the defensive thinking doesn't come from like flight rationale. It comes from not having enough hardware to test this correctly. The late 2020s, Nova. Don't remind me. Where's the EUS? Yeah, that's what I mean. I would delay the program over risking the crew. Bad take, EJ. No way they should hold a launch until they are ready. There's no reason to launch this without a crew. You think so, Kevin? Are you being sarcastic, or are you actually being serious? I can't tell. Ooh. Looky, thank you for these pictures. Yeah. There's the honeycomb matrice right there. There's your backing plate. Your adhesion to the backing plate. There's the honeycomb fiberglass matrice. There's the Avcoat injection, and then there's the top layer on top of that. There's a binder on top of it. I'm being serious. They shouldn't launch this one without a crew. This program is to launch humans around the moon. Really? Interesting. Would you do it, Kevin, even knowing that there's a higher risk than needed for the heat shield? Huh. Do you think there's more risk than the 60s? Yes, absolutely. This is an extremely complicated mission. The amount of risk on this mission is higher than Apollo 8. Way higher than Apollo 8. The reason why is not because we don't know how to do it. Apollo 8, if anything, taught us how to do it. This is not just Apollo 8. They're not going out to the moon and coming right back. This is a combination. This is like combining Apollo 7, Apollo 8, and Apollo 9 all into one mission. I'm not entirely sure that that's good to do if you're not absolutely sure that your heat shield worked. I really think this is the president's work. He wants them to be on the moon. Lisa, the thing is, I mean, you can go pointing fingers at the president or whomever. Honestly, spaceflight timelines are much, 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 much longer than presidential terms, if you really want my honest opinion. This decision to fly the crew with the heat shield was made by NASA in 2023. If you really want to know. And I'm not trying to point fingers. They delayed the mission in 2023 because they wanted to make sure that their analysis on the heat shield was good. This Artemis II was supposed to fly in 2024 or something, and they delayed it to now. They gave it a year-long delay to better understand the heat shield. So the decision to fly this heat shield that is known to come apart with crew was not made by this president. Once again, I'm not trying to play the blame game. I'm just telling you telling it like it is. That's what happened. Apollo 10 was lander testing, correct? That's right. Mm-hmm. They did avoid the risk questions. This mission is carrying a lot of risk. And once again, here's the thing. NASA isn't, it's like I was saying, these guys like Jeff, Charlie, John, they're not going to look at this and be like, well, the heat shield might fail. No. What they're going to do is they're going to try to mitigate the results through analysis as much as possible. And that's what you should be doing. That's right. That's correct. That is the right thing to do. Kevin, I would do the same thing if I was in their position. But I'll be 100% real with you. NASA analysis on different engineering concepts in the aerospace field are the best in the world. There's nobody that even comes close to their analytical prowess, I guess. Right? If they say it's good, it's probably good. However, our simulations and analysis are no match for actually flying. We can get close in our simulation, but your simulation is never going to be 100% high fidelity. It's never going to be 100% of the real thing. We're never going to be able to accurately simulate exactly what this thing does in flight data. There's a whole mathematical theorem about this that has never been proven. Long story short, to make it brief, nothing replaces flight data. Nothing. You could do all the simulation and all the analysis in the world that you want. Nothing will be even worth it until you go and test the heat shield and it comes back how you thought it was going to come back. The people that did analysis and said, the people that did the analysis, the team that did the analysis on this heat shield, on the Artemis I heat shield, are saying that, if we fly the Artemis II heat shield this way, it'll be fine. Right? Those are the same people that did the analysis on the Artemis I heat shield and said it would be fine. Bro, your analysis is wrong. And now, don't get me wrong. They're not just going to use the same, simulation from Artemis I to Artemis II. With Artemis I, if anything, they have a flight datum for what would happen in this particular scenario. But that's just one dot in a plot of simulation, right? Like, you're not going to use one flight. You're not going to change your rationale based off of one flight. There's not enough data points to do a high fidelity analysis with one bit of flight data. This is the reason why SpaceX launches all the time and why they've done all these Starship tests where the thing blows up or it gets cooked through reentry, because they're putting in additional data points to make their simulation and analysis better. You can sit there and try to make a good data set off of one bit of flight data, right? The EFT-1, that doesn't work because that was a different heat shield. And you could try to establish, a high fidelity simulation based off of one data point, which is Artemis I. But Artemis I didn't come back correctly. So they, by definition, are so like they're by definition making their not admitting, they're by definition admitting that they don't know what the nominal trajectory is for this type of heat shield. You have one data point, and your data point was not corroborative to your initial analysis. Okay, so your analysis is here. You said it was going to be good right here. It wasn't good. It's down here. And they're trying to basically connect the dots to a point where the heat shield would be good up here. But that's an abstraction. You don't know for sure. You can plot the points here, but you don't know. It's an unknown unknown. You can do all the analysis in the world. Analysis is corroborated with flight data in systems engineering. That's how it's done. They don't know for sure. You don't know. It's an unknown unknown that frankly doesn't need to be there. Anyway, like I said, I would feel really bad if I didn't say this out loud. Like, it's been jarring at me for some time. Guys, I don't want to alarm anybody. It'll probably be fine. NASA's analysis is the best in the world. Even though it is kind of an abstraction, you know, like, okay, this is what we thought it was going to do. This is what it actually did. So if we change a couple of things, this is what we're going to do to get a safe heat shield. You know, you're connecting the dots in your analysis, so to speak, right? NASA's pretty good at that. They are pretty damn good at it. It'll probably be fine. But I would be remiss in not mentioning it. Wait till China tries this engineering stuff. That's why, personally, that's why I think that the Chinese lunar landing is a lot further out than we think it is.
Discovery,
because they need to overcome these same goals, dude. What are they going to do? Copy our homework? Like what they do? What are they going to do? Copy our blocked avcode ablator? Probably not a good idea. Just saying. That doesn't work. You got it. You have to think about it. They have to go figure out how to do it. You know, with their own capsule. Hey, Tiger Fang, 62-month resub. Yep. Good. Copy our homework. Go ahead. Yeah. Go ahead. They got to figure this out. You know, a manned lunar landing doesn't mean nothing if you can't get the crew back. Because that's what everybody's going to figure. That's what everybody's going to focus on. I ain't going to focus on the landing. Apollo 11 would have sucked if Neil and Buzz died on the mission. That would have sucked. That wouldn't have been nearly as cool as them coming back and showing everybody, yeah, we went to the moon, you know, like. All of this time in simulations, they could have done a flight on Vulcan or Falcon Heavy. Aitor, that's always been my argument, dude. And, you know, the kind of rationale for not flying Orion more was because it didn't have a launch vehicle. If I was Jared Isaacman, I would have Lockheed cook up another one of these heat shields and launch an Orion capsule. Take the Artemis III Orion capsule, put it on top of Vulcan VC6 or New Glenn or Falcon Heavy, something, whatever rocket it would be most at home with, and do another EFT mission to validate this heat shield, to get you more points of flight data. They would do it. What, would they not do it? Of course they would do it. And it wouldn't be that expensive. And, you know, people are going to say, well, what about another Orion capsule? Well, guys, we could just use the Artemis III capsule right now. What is it? What is Artemis III launching soon? It's not launching soon. No, viscosity. I don't care. I don't want to talk about that. Are they playing Kerbal? Yeah. This all goes back to the fact that NASA doesn't have the hardware. With that in mind, I think that might be affecting their judgment a little bit. But like I said, Trey, I'm just a YouTuber and Twitch streamer, dude. What do I know? Look, if Jared Isaacman says it's okay, I believe him. I believe him. Begrudgingly, but I believe you. You know? Angry Beard, the new NASA administrator, Jared Isaacman, he's trying to fix that. You know? Any thoughts on a heat shield shape designed as interlocking puzzle pieces and not blocks? My problem with that lunar lander is that you're still going to have seams. The seams are what get you with the block ablator. If you want my honest to God opinion about this, here. That right there. We couldn't 3D print that? This is fiberglass. Apollo used a fiberglass honeycomb matrice. Why couldn't we 3D print this and eliminate seams in the heat shield? You know, NASA said, oh, we didn't have the technical expertise to do something like this. Well, there's no supply chain for fiberglass honeycomb matrices. We didn't have any supply chain for that. We did have a supply chain for the blocked heat shield. I don't like that. I don't like that at all. You're NASA. You should be innovating. You're telling me you can't make something that they made 56 years ago? Oh, we can't do that? You're telling me you couldn't use robotic arms to do the injection? Because how they made the Apollo heat shield was, dude, they hung a dude from a hoist over the fiberglass matrice and gave him a caulking gun and said, fill up each one of these holes. That's how they did it. I'm not even kidding. They hung a dude from the ceiling with a gun over the fiberglass heat shield and said, fill up every hole. And when you need more, just we'll tug you back over here. We'll give you more. Give you more Avcoat. How old is Orion's tech again? Older than the advert of more accessible advanced 3D printing. Yeah, Hokie, I refuse to believe that. Yeah. I mean, yes, that's true, right? But I refused, like, the rationale there makes sense, okay? For switching to the block ablator because it's cheaper, you can quality test it. That's a huge one. That's a huge benefit. But being able to quality test it doesn't mean dick if it doesn't work. Like, oh, I quality tested this Takata airbag. This will make the car safer. No, it won't. No, it won't. It's gonna make it, that does the opposite of that. If you guys are familiar with Takata airbags, about 10 years ago, I think it was 10 years ago, there was a supplier for the automotive industry named Takata, and they were making airbags for cars. The airbags, when they inflated the housing for them, right, didn't fragment in the way that they thought it was going to fragment. And instead of an airbag inflating and absorbing the impact of when you get into a collision, the metal actually became a shrapnel grenade blowing up in your face during a car accident. Lovely. That, you know, it doesn't matter. Oh yeah, the block ablator heat shield is better. It's easier to quality test the components to make sure that it, you know, that make sure that they're good. Yeah, that means nothing if the heat shield doesn't work. I feel like I'm taking crazy pills here, man. Yeah, there you go. Look. There, that. Thank you for the picture. Yeah, see, freaking caulking gun, filling in each hole by hand of the fiberglass matrice. Brother, you telling me we can't automate that? You telling me we couldn't 3D print? We couldn't 3D print better matrices for better mechanical adhesion of the heat shield? You've got to be kidding me. It's like, I don't like that NASA's like, no, that's too innovative. We can't do that. Like, what? What are you talking about? You're NASA. What do you mean? If they had this mentality in the 60s, they would have said, no, it's better to just fly around the moon because we don't have a supply chain for a lunar lander. You know, we could just say we got near the moon. You're NASA. Are you kidding me right now? That's interesting, YG. And how the heck did this get through testing? It didn't, Aitor. There's no way to test this. There's no way to test it except at a small scale. But the NASA, the Apollo engineers in the 60s knew this. They knew that there was no way to test it. So once again, this is what I mean about offensive thinking. Build the heat shield in a way where you're absolutely sure nothing is going to go wrong. It might take a little bit longer to build it this way, and you might not be able to do the testing, right? But build it in a way that you know is going to work. Because expediency is key here. Could they have probably figured out a better way to do it? Yeah, sure. Sure. But that doesn't mean nothing if you don't get to the moon by 1970, because that was the expectation, right? So build it in a way you know is going to work. We didn't do that here. That's what I don't like that. I don't like that NASA's like, well, we can't do that. It's too complicated. Bro, are you kidding me right now? Are you kidding me? I don't like that. I don't like that at all. That, now, keep in mind, that is like completely, it's not completely different, but I don't, what do you mean you can't do it? What do you mean you can't do it? What does that mean? You're NASA. I have a horrible thought going through my head regarding Orion, and that's a massive what if, and I think you know where it goes. That's what I'm saying, Chris. Bro, we're in a high-stakes situation, but admitted by the president that we are in a space race with China. I mean, personally, I don't think we are. I don't think China's anywhere near getting people to the moon, because they have to solve these same problems, right? I don't think they're anywhere near that. However, you know, he said we're in a race, so expediency is key here. Now I feel bad about bringing up the topic that caused a rant. No, Hokie, I decided to, I'm not ranting ridiculously because this is a normal thing. I decided to say this piece here for this segment of the stream so I don't have to say it again. If this comes up again, I'll just be like, go watch this VOD. You know? I'm just saying it now before they even start the mission, before they even roll out, and I'm saying my piece, and honestly, I'm probably not going to bring it up again. Because I also very much believe this is not really engineering and analysis. I very much believe in bad juju, like Bill Harwood bringing up Challenger during that press conference. Don't do that. Don't do that. So, yeah, like I said, this is the last I'll say about it. You know, don't, why even go there? Why even talk about it, man? Well, Chris, that was the whole topic of discussion here. Article, what did you link here? This is the Textron team readies Orion heat shield for shipment to KSC. What am I looking at here? Is that the 12 years ago? So that's the EFT-1 heat shield. Yeah, ruinous. Yeah, I know what you mean. No. Yeah, see? Look at that thing. No seams. No seams anywhere. See that? It looks like reinforced concrete. It doesn't look like bricks. Yeah, see, the EFT-1 heat shield was a copy of Apollo. Anyway, all right. Yeah, no seams, dude. All right. Okay. How does the planned Artemis II reentry compare with Artemis 1? Artemis 2 is using Apollo's reentry trajectory. The skip trajectory exacerbates the charring and spalling, Linpron. Okay. Marcon, Devil's Advocate. Yeah, dude, let's go. If I plays Devil's Advocate, do you think NASA should do uncrewed test every time they move to a new block of SLS? New SRBs, upper stage, etc. And if not, what's the difference between that and changing the heat shield? Marcon, it depends on what you changed. It really depends. This isn't black and white. Aerospace is gray like that. It depends on what you changed. And I suppose that's like the difference between like an incremental upgrade to something and like a redesign. This heat shield is redesigned. The future block variants of SLS are incremental changes. They're upgrades to existing stuff, like boosters or engines or the upper stage. But even the Block 1B version of SLS with the exploration upper stage, the propulsion, which is the part that needs to be tested the most, are just RL-10s. We have plenty of flight heritage with those things. So you're mitigating risk in that regard. It really depends. It depends on what you changed. It depends on if it's redesigned or if it's an incremental upgrade. Incremental upgrades, no, I don't think you need to do uncrewed tests with. There's enough data points there to be able to connect the dots, especially if you do good ground testing, right? To retire that risk as much as possible. Redesigning the heat shield is something you cannot test on the ground. We can't test heat shields down here, Marcon. That's the other thing. I forgot to mention that. You can't test heat shields down here. Can't test them. We don't have a way to simulate reentry heating. So you can't test them. You won't know if it works until you send it. You can't have like a wind tunnel that shoots plasma at a 5-meter wide heat shield. We don't have an arc jet big enough to do that. Unless somebody wants to put a heat shield in front of a rocket engine on a test stand and fire it, I think that's not necessarily the stupidest idea. Can't they launch dummies on Falcon 9s? Well, that heat shield that I just showed you, Yoda, was a dummy that they launched on a Delta IV Heavy in 2014, and then redesigned the heat shield because they said that was too hard to make. I'm not even kidding. That is Amit Garcia's, that's his words. Number 2 at NASA. He said, well, this heat shield worked great, but we redesigned it because that was too hard to keep making. I'm serious. That was the rationale. It was too hard to do that. Blocked heat shields, we have the supply chains for. It's easier and cheaper to make that. Those are his words almost verbatim. And I was flabbergasted by that. Like, what? What do you mean? What do you mean it's too hard to make? What are you, crazy? We're talking about a heat shield here. This is a heat shield. It's not a matter of cost. It's a matter of it working. You kind of have to make sure that it works. It doesn't matter if you save money on it if it doesn't work. Yeah, they said it was too hard. They said they didn't have the supply chains. Yep. We don't have the supply chains to support that kind of program. We do have the supply chains for a blocked Avcode ablator, so we went with it because it's already pre-existing and it's cheaper. And we can inspect each block. We can QA each block before we, put the heat shield together. Well, that's all fine and dandy. But you're forgetting one thing. None of that means anything if the heat shield doesn't work. It has to work. And guess what, guys? They're redesigning it for Artemis III. And that's my big problem with this. I think whoever made the design decision to redesign the heat shield in 2014 at NASA is stupid. Yeah. That's bottom dollar penny pinching nonsense. You can't do that with spaceflight. You just can't. I'm sorry, you can't do it. You can't do that. That's how people get hurt. How about a supply cable? Yeah, that might work. Sealass, what's up, Lovey? What's on your mind? Been in the engineering industry, albeit not in the cutting edge of physics like this, for 15 plus years now. We have a saying, hope isn't a strategy. Yeah, you can wish in one hand and crap in the other and see which fills up first. Check Discord. Jared talked about the press conference length. Oh, he did. Give me 1 second. Okay, what did he say about that short press conference? Transparency matters, especially for one of the most important human spaceflight missions in recent history. At my direction, the last Artemis II blog update went into greater technical detail, and I will ensure there's more time for Q&A at events like this going forward. Cool. Yeah, sweet. Yeah, that was Starbase Live. There's a SPMT going by. Binary, that's you? Oh, nice. Killer. I will like your tweet, my friend. I don't want to be loquacious about this discussion. It's getting a bit monotonous. Did you just come from English class or something, Sea Kraken? Like I said, I'm just trying to have this be the all-encompassing thing. And look, I don't believe in bad juju during a launch campaign. So from here on out, guys, we're cheerleaders. We're cheerleaders for this. Right? I said my piece. I ain't bringing it up again. Loquacious. This discussion is getting monotonous. Well, I find your comment very shallow and pedantic. Well, yes. Shallow and pedantic. Hey, Chief, what's going on? How's your back? It's stiff, but I'm getting there, dude. Shallow, dang it! Yeah, he's always watching. That's good stuff.
Discovery, go at throttle up.
Scoff, 47-month resub. So here's the real issue. NASA are boxed in by the contracting structure. The program isn't hardware rich, James. That's it, man. You nail on the head. That's the real issue here. However, with all that being said, that's pretty nice. I like that. Yeah, I don't hate that. Yeah, I don't hate that at all. That's pretty awesome. Yeah, we should make more. I agree. Will Philip be on Flame Trench? Seems like a spicy conversation could happen, even if NSF called you out on socials for spicy content. Wait, what? What did I do? Oh God, they're talking about me? Oh gosh, I hope I didn't piss anybody off. Wait, what do you mean they called me? Who did? Philip will be on tomorrow's rollout stream. Oh, okay. Kevin! Speaking from a non-technical perspective, does Block 1 or Block 2 look better? Are we talking just purely aesthetics here? Like straight aesthetics? Okay, if I'm gonna be real, Sea Kraken, I think Block 1 is a great looking rocket. I hate its performance, but I think it's a pretty it is really that looks right. It looks correct. Let me put it that way. The press conference has ended, Leon. It was only an hour, but I did some Q&A myself after it. That's why. From pure aesthetics, that looks real nice. I do like it. That's like, you look at that and you're like, yeah, that's what a rocket should look like, man. With that being said, dude, Sea Kraken, if I was going to answer your question, I like Block 2 or Block 1B. I think Block 1B is the best looking. And I know the exact picture. I know the exact picture that made me think this way. It's a render that was done by NASA of the EUS with Orion. Look at that. Look at that picture. That just, I mean, I have my my quarrels, another big word. I have my things with the EUS. I don't think that's really good for doing lunar exploration, but that's not necessarily what it's designed for. However,
Discovery,
that looks pretty good, man. I don't hate that. Red 8, 129 month resub. That ooh. I like that. You know, like you get the capsule up at the front, payload bay behind it, and the universal stage adapter, the orange for it, like cluster of engine. That looks good, man. It's a pretty good looking rocket. This week in our 85th episode, EJ will get spicy when talking about NASA's SLS rocket about to be rolled out at Kennedy Space Center. I will? Why am I getting spicy? Oh, God. I really hope I don't have to repeat the same conversation that I just had on Flame Trench. I don't want to do that. 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 Now make it reusable. Hokey, I would like the EUS more if we made the stage, if we built loiter capability into it from the start. Yeah, I agree. That'd be a good idea. Heck, Pokey, you want to hear a real humdinger? I actually thought that if you give this thing loiter capability, if you give the EUS loiter capability and boil-off mitigation, just use the EUS to land on the moon. Yeah, there, I said it. Why not? You launch an SLS Block 1B with no Orion on the top and just the universal stage adapter as your fairing. And inside of the universal stage adapter, you have an ascent module for the most part. Actually, you probably don't even need an ascent module. The EUS has enough delta V and thrust to weight to be able to land on the moon from even rectilinear halo, right? So you do an SLS launch with the EUS lunar lander variant that can loiter and has boil-off mitigations like a sun shield or something, right? And then you launch an SLS Block 1B, right? Heck, the SLS Block 1B launch with the crew could have your ascent component in here. And Orion could bring that to Gateway or bring it to rectilinear halo. You could dock the ascent component to the EUS in lunar orbit and then go down to the surface with a reusable EUS. If you have to talk about the heat shield, you have free reign to have the NSF guys use images I sent to you. Those are from your Smithsonian trip. I actually might do that, dude. Thank you. It was posted a couple minutes ago into your spicy rant, so yes, you will. Oh, crap. I know it's not space related, but I was wondering if you were going to play Derail Valley again anytime soon. I really hadn't planned on doing it, Black Eagle, but I wouldn't be against it. Maybe when a new update comes out. That's usually a time to go jump back into games when they update them. Anyway. On another topic, how far along is the CAT KSP, the career KSP going on? You got any update? I guess you would. I don't understand what you mean, Yoda. If you're talking about the KSP playthrough, we're just on a My Winner car kick right now, dude. We'll get back into KSP soon. Oh, the CAT KSP. Oh, KSA. I am doing some consulting work on something with them as of now. I can't say what or where, just where I'm getting a little more involved in consulting and advisement for how the game should play for certain aspects. And that's really all I can say. I'm working on them with it. They're working on building out this game, and what I will say is that they're really trying to make it a good spiritual successor to KSP. They're trying to make it feel like KSP. Like they're trying to make it a real spiritual successor, and that's all I'll get into. I don't want to get into the weeds about it, about what I'm doing right now. You'll see it soon, trust me. Have you spoken to Dean? Not recently. I was in a meeting with him a couple of weeks ago. It was more than a couple weeks ago. That was like 2 months ago. But yeah, doesn't matter. Hey, Viper, 18-month resub. Hooch with an 18 as well. Will you be live for Rollout? Yep. Mm-hmm. Like, guys, they're being pretty transparent. Like, they said I can... Like, what I told you is, like, we're working on features that are trying to... And we're trying to make it... We're trying to make it feel like... capture that same fire in the bottle as KSP. You know? Like... You play Kerbal, right? And then you play, like, Juno New Horizons. Like, what is it called? Juno New Horizons? That's what is that? What are the other spaceflight simulator games? I don't even remember. Those other games are awesome, but they don't feel like KSP. KSP, really captured, like I said, fire in a bottle. We're trying to make sure that this game does that. Yeah, Sea Kraken, like I said, I can keep a secret. It ain't no thing. But yeah, I mean, not that their RocketWorks is really trying to keep it under wraps. The only reason why they don't want to tell people, like they said, don't tell people what I'm working on, is because they're not ready to show. They're not ready to show a minimum viable product. You can't. Like, they didn't give us the playable demo until they got, like, the orbital mechanics really working correctly, right? The features and parts of the game that I'm working on, or that I'm consulting with them on, are parts that aren't finished. They're building them right now. There's nothing to really show. No, Dinosaur. Simple Rockets, that's what it's named. Just saw Isaac Moon reply to concerns about the short Q&A on Twitter. Love this guy. Yeah, dude, that's good, man. I really hope KSA will have a good multiplayer. That's my evil plan to teach your girlfriend about spaceflight. I can't speak to multiplayer, Marcon, and I can't speak to it because I frankly have no idea if they even plan on doing that. Like, it's not that I can't speak to it, that they have something or they're building something. I don't know if they're trying to do multiplayer. I don't remember. I'm sorry, man. Figure I'll be honest though. I don't remember. Dean said there will be multiplayer, and they already have chat working between clients. James, we'll play My Winter Car on the other side of Flame Trench here. Actually, what time is it? It's 2:30. Could probably get 2 hours of summer or winter car in right now if we want. Want to go grind out some missions, and then yeah, after Flame Trench, we're gonna play My Winter Car again. Thanks, man, for the response. I'm definitely keeping an eye on the project. Yeah, guys, yeah, keep your eyes peeled on KSA. They are working on it. They're doing work, and I am consulting on it. I don't get paid to do it. I don't want money for that, because if the game is good, I'll make money there. Like I don't get paid for that. I do it. I consult in my free time because I want, if they capture lightning in a bottle again, and KSA is amazing to play and it's just as fun and engaging as KSP, well, that's job security for me, dude. You know? Give a stream re-entry. No, never streamed at B0. I did see they have a basic editor and decoupling in KSA now. Ever cook a Kerbal? I've never cooked a Kerbal, Bill. Most of the Kerbal deaths that I have experienced in all of my saves are a Kerbal hitting the ground too hard. Yeah, I don't think I've ever had a Kerbal die on re-entry. Ever. It's because I do my homework. Just saying. Yeah, the ground coming up too quickly is what usually gets my Kerbals. Yeah, exactly, Hazanku. That's why Rocketworks chose to do a crowdfunding model with KSA and use profits from Stationeers and Icarus to fund KSA's development, to make sure they can incubate it and make it right without having to worry about, you know, a financial runway or deadlines or any of that nonsense. Yeah, no, I wasn't like I was a little worried about it, but, you know, actually, Zonko, it was a pretty funny conversation. I asked them about it, and I'm like, guys, are you sure that this is the right move? I mean, what if nobody funds it? And they said, you know what they said to me? They were like, how could you... This is a conversation I had with Hypemare. He was like, that's weird coming from you, of all people. And I'm like, what do you mean? And they're like, you're the one that, you know, doesn't expect anything from people, and you do good work and people reward you for it. We're doing the same thing with the game. And I'm like, oh, okay. All right. I get, all right. Yeah, that makes a lot of sense. I don't know how I didn't realize that. They're like, that's what you do. And I'm like, oh, you know what? You guys are smart. All right. Okay, geek. Yeah, just needed the perspective. Yep, now you're noticing the Cleater shirt. That's right. Yeah, I was like, huh, that makes a lot of sense. All right. Well, that's because you're freaking stunned. Oh yeah, I'm freaking stunned there, bud. All right. Speaking of stunned, let's play Winter Car. We could probably play for about 2 hours here, and then we'll go. Yeah. But once again, fellas, the heat shield thing, I ain't bringing that up again, because here on out, we don't want any bad juju for this mission. The Artemis II mission needs our positive energy. Okay, so we're positive mental attitude from here on out. Okay. If anybody ever brings up the heat shield, I'm just going to refer them to this VOD. All right. So you guys know the drill. I'm going to jog the YouTube VOD, so this kind of stays as its own video on YouTube. On Twitch, don't go anywhere. We got My Winter Car, quick 2-hour session of My Winter Car, and then we have the Flame Trench. which is a podcast that I do for NASA Spaceflight, a space flight news outfit that are good buddies of mine. And then after that, we have more Winter Car. Still plenty of stream left. So on YouTube, stand by for loss of signal as expected. I'll be right back. Twitch, don't go anywhere. And we're clear off of YouTube. All right, let me just change up the titles here. It's simple. We'll title this, It's Simple. Jobs to make money for car parts. My Winter Car Attempt 3.